Do you ever just look up at the night sky and wonder what was here before all of this? For most of history, that was a question for philosophers. But today, physicists think they're getting close to an answer. And honestly, it could change everything.
Yup, this is the big one, isn't it? The ultimate question. We're told our universe exploded into being from a single point about 13.8 billion years ago. But what about the moment before that? Was there just nothing? Or was that single point less of a beginning and more of a doorway?
All right, so here's how we're going to tackle this. We'll start with the question itself, then dig into a major problem with the Big Bang Theory. From there, we'll look at a new cosmic rulebook that leads to this wild idea of a great cosmic bounce. And finally, we'll see how scientists are looking for evidence and what it means if they find it.
So let's get right into it. The whole what came before question isn't just a late-night thought experiment anymore. It's now something physicists are actively trying to solve with real math and real observations. They're hunting for a testable answer.
Okay, so to get why we even need a new theory, you have to understand the big flaw in the one we have now. You can think of the standard Big Bang model as having a massive 404 error page right at time 0, a point where all our knowledge just completely breaks down.
And that error message has a name, the singularity. It's this idea that everything, and I mean everything, every star, every galaxy, you, me, was once squished into a point with zero size and infinite density. The problem is, our laws of physics, they just stop. They don't work there.
You know, in physics, when your equations spit out the word infinity, it's not some profound discovery. It's a giant red flag. It's the math basically screaming at you, nope, try again, your theory is broken. It just means we've hit a wall.
And here's why the wall exists. We have these two incredible rulebooks for how the universe works, right? General relativity, which is amazing for explaining huge things like galaxies and gravity, and quantum mechanics, which is perfect for all the tiny stuff. But at the singularity, the universe was both incredibly massive and microscopically small. Our two best theories give completely different answers, and the whole system just crashes.
So this leads to a really cool idea. What if we've been using the wrong rulebook? What if we could write a new one, a unified theory that works everywhere for the big and the small, even at the very beginning? And the missing piece, the key insight, seems to be this. We've always treated gravity as this smooth, predictable force. But what if, when you get down to the tiniest scales, gravity itself gets weird and fuzzy? What if it has to play by quantum rules too?
Because as soon as you make that one little change in the equations, something amazing happens. That singularity, that point of infinite collapse, it just disappears. And in its place, you get something way more elegant, a bounce.
I love this quote because it gives you the perfect mental image. Instead of a universe crushing itself out of existence, picture a previous universe shrinking down. As it gets super dense, this new quantum gravity force kicks in and starts to push back. It's like a compressed spring that's been pushed to its absolute limit. It doesn't break, it just powerfully springs back out.
So the story goes something like this. First, a previous universe contracts. It gets down to a microscopic size, super tiny, but not zero. Then that quantum gravity force acts like a repellent, stopping the collapse. That's the bounce. And that bounce is what kicks off the expansion of our universe.
And that, right there, is the mind-blowing takeaway. The Big Bang wasn't some magical moment of creation from nothing. It was the moment a previous universe rebounded, turning an epic collapse into an epic expansion.
Now, I know what you're thinking. This is a really cool story, but is it actual science? Absolutely, and here's why. A cosmic bounce wouldn't have been a perfectly clean event. It would have left behind specific, testable echoes that we might actually be able to find today.
So scientists are basically on the hunt for three key clues. First, they're scouring the cosmic microwave's background, the oldest light in the universe, for any weird patterns or scars left over from before the bounce. Second, the bounce would have created a unique signature of gravitational waves, a very specific kind of ripple in space-time. And finally, of course, the math has to work. The new equations have to describe the whole process smoothly without ever hitting that dreaded infinity.
So, why does this all matter so much? Well, if this idea turns out to be right, it doesn't just add a new chapter to our cosmic story. It fundamentally rewrites the entire book. Think about it. The old story was a one-time thing, a universe that appeared from nothing and is just going to expand forever. But this new story, it's a cycle, an eternal loop of cosmic contraction and expansion,
death and rebirth, stretching infinitely into the past and into the future. The whole idea of a creation event might just be an illusion.
And that leads to this really profound conclusion. The ultimate question: what came before the beginning? It might have a stunningly simple answer. There was no beginning. There was only an endless cosmic rhythm.
And that's really the thought I want to leave you with. Are we just the latest pulse in an endless series of universes? Is our cosmos just one note in an eternal song? The search for those cosmic echoes is on, and it might just tell us the answer.
And it's exploring these kinds of incredible ideas that pushes all of our knowledge forward. This explainer was brought to you by the Varia One platform. If you believe in pushing the boundaries of knowledge, hit that like button and subscribe for more breakthroughs. Dive deeper into the research and explore more on the Varia One platform. See you there.